So the next guy in line is Sebastian, and Sebastian is taking this microphone. Very glad. So just like this. Sebastian, bleibst du hier? Nein, das macht alles der Techniker. Nicht der Techniker. It's none of your business. He's the German one. He feels responsible for everything around. So what are you doing in the Unicat cluster?
I'm working on enzymes and biotransformations, making new antibiotics, finding out how to make.
Sounds exaggerated. Very good. So, you want to start now?
Yes.
Very good.
Okay, so I'm going to tell you about a detective story. So I'm going to transform him into one of the most famous detectives of all time. Well, Watson. I've been working on this case, and it's really driving me crazy. I really can't think of how to solve it, so I'd really like your help in this. So I'm going to talk about the case of the phantom enzyme, and we call this phantom enzyme that deals all the rays. So this is the crime, and as far as reactions go, this really is one of the perfect crimes. So you're taking two starting materials and you make this really complex and beautiful product with a lot of control and selectivity. This is what's called the Diels-Alder reaction. And chemists know this in the test tube for a long time. But also in natural products, we see the same motive. You see here this circle highlighted in red is in a lot of natural products. And it's tempting to think, well, why nature might use this reaction also to make these compounds, and why do we care about how nature makes these compounds? For example, lovastatin is a cholesterol-lowering drug, so you can keep eating a lot of meat and eggs and not get sick from it if you take lovastatin. And lovastatin is made by these microorganisms, and if we can understand how the microorganisms make it, then we can make better compounds. And here's really where the murder happens. So we know basically how the microorganisms make the compound on the right. And it looks a lot like lovastatin already. But we don't know in the crucial step of this compound, how does this work? And because chemists know this reaction in a test tube, you could assume that this is just a death of a natural cause. So no, there's no murder here, but I tell you, this is murder. There must be an enzyme that catalyzes this reaction. It's too good to be true not to be developed in nature. Nature is too clever to not have the Diels-Alder rays. So let me introduce you to the suspects for this murder. Suspect one is called the oxidizer. The oxidizer does a little innocent reaction, so it oxidizes this little hydroxyl group to an aldehyde group, but the victims then get so electronically destabilized that they cyclize and die. So you could just think, oh yeah, here are all the prerequisites, so victims died of a natural cause. But if you look carefully at the evidence, there's two ways this can happen. On the left, with your arms spread out, and on the right, with your arms in like this. So when we look at this reaction, normally we would think if it happened with a natural cause, you would get the endo cause, right? But when I got to the scene of the crime, I also saw a lot of this exo cause. So from that, we think that the oxidizer had something to do with this. Second suspect is the degasser. The degasser, the signature move is you always find a balloon filled with carbon dioxide and you find some water splashes on the floor. What the degasser does, it combines these two molecules and then makes the same ring structure, but we don't recognize it because it's so unstable, because it has CO2 in it, which gets eliminated. That's why you find the balloon. then this molecule is still unstable because it can eliminate water. That's why you find the water splitters. Third suspect is the twister. The twister, you would think that he would be involved in this, but if you look again carefully at how the body is placed, then you know that when this victim cyclizes and dies, the natural causes, you would see the one on the right much more often than the two on the left. But what we actually see is that we have a lot more of these structures where the hydrogens are pointing like this, or like that. So that's why I think that the twister was involved in this murder. Final suspect is suspect 4, the transambulator. Transambulator has a signature token that he leaves on at the seams, which is this Gordian knot, as you can see here in the yellow. Now, the transambulator takes this very complex molecule and makes a few bonds, which you recognize now as the Diels-Oler reaction. Now, who was it? Was it the oxidizer in the kitchen with the hydrogen peroxide? Was it the twister in the kitchen with the spanner? Or was it even the transambulator in the hall with the lead piping? Well, Watson, I'm going to give you my best shot in this case. It couldn't have been the oxidizer because he just bleached the hair at the hairdressers and then went to the pub, and the victims died much later, so he has a alibi. It can't be the degasser because we know he uses the laws of thermodynamics to help him, and in this case we didn't see any traces of that. So he needed the accomplice to accomplish his crime. So it can't be him. Now the twister has confessed, but there's some details of the crime that he couldn't quite tell us. So we think that he just confessed under pressure, and also we used some illegal surveillance data to convince him to confess, so we can't use that in court. The transambulator is probably the closest we got to the murder, but this reaction is so complex that it could just be the one example, and it doesn't explain all the other murders, so there might be quite a few more suspects out there that we haven't found. So, like a lot of big cases in science, even I, Sherlock Holmes, can't solve this at the moment, and this case is still under investigation. Thank you.
It's like the loop on the way to here. We had some pupils that realized, oh yeah, it's Friday afternoon. They started to take out their mobile discotheques. And, yeah, they had something like Ishuto or some rap. We had that in the crime documentary.